Lesson number 9, Linear Law. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. Now, let's start the lesson with a discussion of a question why we want to learn linear law. So we know that linear equation is y equals mx plus c, where m is a gradient. So from here, this is a straight line, and this is the gradient. C is the y-intercept, so this is c. Linear equation is preferred by many researchers as it is easy to calculate, understand, and analyze data. However, in many instances, the relationship between two variables x and y are not linear. Linear law is used to reduce nonlinear functions to the linear form, which is capital Y equals m capital X plus c, where capital Y and capital X can be more than one variable. Now, let's learn how to convert nonlinear to linear function. In general, the equation is capital Y equals m capital X plus c. Here's the first case. The nonlinear will be in the form of y to the power m equals a x to the power n plus b, where we let y equals y to the power m, capital X equals x to the power n, and when you plot the graph, the x-axis will be the x to the power n, and the y-axis will be y to the power m. So this is a straight line. Here are a few examples. The first example is y equals 3x squared plus 1. We can let capital Y equals y. The gradient is 3. Capital X is x squared. The c is 1. Here's another example. 1 over y equals 5 sub x plus 2. Capital Y equals 1 over y. The gradient m is 5. The capital X is sub x. And the c is 2. Here's another example. 3 over x plus 2 over y equals 1 over 2. So we need to rearrange this equation, which is 2 over y equals negative 3 over x plus 1 over 2. Then we divide 2 for both sides. We get 1 over y equals negative 3 over 2 bracket 1 over x plus 1 over 4. From here, we can let capital Y equals 1 over y. The gradient is negative 3 over 2. Capital X is 1 over x. And the c is 1 over 4. So this is the first case where the nonlinear function is in the form of y to the power m equals a x to the power n plus b. Second case, the nonlinear function is in the form of y equals ax squared plus bx plus c. So we can rearrange this equation by dividing x for both sides. We get y minus c over x equals ax plus b. Hence, capital Y equals m capital X plus c. The capital Y equals y minus c over x. The gradient m is equals a. Capital X equals x. The c equals b. And the x-axis will be x. The y-axis will be y minus c over x. This is the straight line. Number 3. The nonlinear function is in the form of y equals a over x minus b. So if this is the case, we can rearrange this equation, which becomes y times x minus b equals a. So we expand, we get xy minus by equals a. Therefore, xy equals by plus a. Capital Y equals m capital X plus c, where we can let capital Y equals xy, the gradient m equals b, capital X equals y, so c equals a. When you plot the graph, the x-axis will be y, the y-axis will be capital X, will be xy, and this is the straight line. Or from the equation y equals a over x minus b, so it will be 1 over y equals x minus b over a. Therefore, 1 over y equals 1 over a x minus b over a. So capital Y equals mx m capital X plus c. We can let capital Y equals 1 over y. The gradient m equals 1 over a. Capital X equals y. And the c is negative b over a. So when we plot the graph, the x-axis is y, the y-axis is 1 over y, and this is the straight line. Case number 4. The nonlinear function is in the form of y equals ax to the power b. So we can log both sides, which we get log y equals log ax to the power b, and it will be log y equals log x to the power b plus log a. Log y equals b log x plus log a. Hence, we can compare the capital Y equals m capital X plus c, the capital Y equals log y, the gradient m equals b, the capital X equals log x, and c equals log y, log a. So in the plotted graph, the x-axis will be log x, the y-axis will be log y, and this is a straight line. Case number 5. The nonlinear function is in the form of y to the power b equals 10 to the power of x plus a. So we can log both sides, which we get log y to the power b equals log 10x to the power a. And we know that log 10 will be 1. Therefore, the equation becomes b log y equals x plus a. Log y will be equals 1 over b x plus a over b. So capital Y equals m capital X plus c. The capital Y equals log y. The gradient m equals 1 over b. The capital X equals x, and the c is a over b. When we plot the graph, the x-axis will be x, the y-axis will be log y, and we can get a straight line. Now let's look at one example about converting linear form to nonlinear form. Given this diagram, the variables x and y are related in such a way that when y minus 3x is plotted against x squared, a straight line passes through 2, 1 and 5, 7 is obtained. Find number 1, y in terms of x. Number 2, the value of x when y equals 62. So here is the solution. Number 1. First, we want to find the gradient of the graph, which is m equals 7 minus 1 over 5 minus 2. Okay, by using the coordinates of the 2 points given, and we get the gradient is 2. So now we can form the equation using this formula. Capital Y minus capital Y1 equals m bracket capital X minus capital X1. So it will be capital Y is y minus 3x. The capital Y1 will be 1. The gradient is 2. Capital X is x squared. And capital X1 is 2. So now we can expand the bracket. It will be 1 minus 3x minus 1 equals 2x squared minus 4. Make y the subject. We get y equals 2x squared plus 3x minus 3. So this is the equation y in terms of x. Number 2, when y equals to 62, just substitute the value into the equation. 62 equals to 2x squared plus 3x minus 3. Solve the equation. So 0 equals to x squared plus 3x minus 65. So we'll get 0 equals x minus 5 times 2x plus 13, x minus 5 equals to 0, or 2x plus 13 equals to 0, x will be 5, or x will be negative 13 over 2. Now you can try this example yourself. Given this diagram, the variable x and y are related in such a way that when y over x is plotted against set x, a straight line passes through 2, -1, and 6, 15 is obtained. Find 1. Y in terms of x. 2. The values of y when x goes to 16. You can pause the video and try to solve it yourself. Here is the solution. Number 1. First, we want to find the gradient of the graph, which is m equals 15 plus 1 over 6 minus 2. We use the coordinates of the 2 points given, so we get the gradient is equals 4. Now we can start to form the equation. So with capital Y minus capital Y1 equals m bracket capital X minus capital X1. So capital Y will be y over x plus 1. So equals m is 4. So equals 4 bracket set x minus 2. Then we expand y over x plus 1 equals 4 set x minus 8. So y over x equals 4 set x minus 9. So we make y the subject. It will be y equals 4x to the power of 3 over 2 minus 9x. So this is the equation y in terms of x. Number 2, when x goes to 16, just substitute the value into the equation. It will be y equals 4 times 16 to the power of 3 over 2 minus 9 times 16. And we get the y equals 116. So do you get the answer correctly? Now, let's look at this example, finding the values of unknown constants. The table below shows experimental values of two variables x and y. So here is the table. Given that x and y are related by an equation of xy equals a plus bx, where a and b are constant. 1. Express this equation in a form suitable for drawing a straight line graph. 2. Using a suitable scale, draw the graph for the given data and use it to estimate the value of a and b. So here is the solution. Number 1. So from the given equation, xy equals a plus bx. Okay, y will be equals a over x plus b. So now we can plot the graph of y against 1 over x because the capital Y is the y, the capital X is 1 over x, the gradient is a, the c is b. So we need to calculate the value of 1 over x. Okay, so from the data given, this is the value that we get for 1 over x. And now using the table that was obtained just now, we can start to plot the graph of y against 1 over x. Here is the x-axis and here is the y-axis, where the x-axis is 1 over x, the y-axis is y. Then we can draw the scale. For the x-axis, we can draw 2 units to 0.1 units. We get 0.1, 0.2, 0.3, 0.5. For the y-axis, the scale is 2 cm to 10 units. So 10, 20, 30, 40. Now we can start to plot the graph. The first point coordinates is 0.5, 38. So this is the point. The second point coordinates is 0.25, 21, 3. So this is the point. Continue with the third point, fourth point, and the last point. Now we can join this point with a ruler. So we can draw a straight line joining all the points. Okay, so once we got the graph, now we can find the values of A and B. So we know that the B is the y-intercept. So here is the point B. From the graph, B equals to 5. And A is a gradient. So we want to determine the gradient of the graph by choosing 2 points. So usually we'll choose the 2 points which are not any of the points on the table, and their coordinates we can read easily. So let's say I will choose this point. The coordinates is 0.46 and 35. Another point, the coordinates is 0.07, 10. I can draw a right angle triangle and get the gradient, which is A, equals 35 minus 10 over 0.46 minus 0.07. And the A is equal 64.1. Now, you can try this similar example yourself. The table below shows experimental values of two variables x and y. Here is the table. Given that x and y are related by an equation of y squared equals p to the power of x over q, where p and q are constants. 1. Express this equation in a form suitable for drawing a straight line graph. 2. Using a suitable scale, draw the graph for the given data and use it to estimate the value of p and q. 3. Estimate the value of x when log sub y equals 0.7. You can pause the video and try to do it yourself. You should plot the graph on a piece of graph paper. Here is the solution. So number 1, from the given equation, y squared equals p to the power of x over q, we can log both sides, which become log y squared equals log p to the power of x over q, and it will be 2 log y equals log px minus log q. Therefore, log y equals log p over 2 x minus log q over 2, where the capital Y is log y, the gradient is log p over 2, capital X is x, c is negative log q over 2. Now, we want to draw the graph. Before that, we need to determine the values of log y. From the given data, these are the values of log y. Now, from the table that we have obtained just now, we can start to plot the graph. So this is the x-axis and this is the y-axis, where the x-axis is x, the y-axis is log y. Now we draw the scale. For the x-axis, 2 cm is 1 unit, so 1.0, 2.0, 3.0, and so on. And for the y-axis, it is 2 cm to 0.4 units. So 0.4, 0.8, 1.2, 1.6, and so on, right? Okay, now we can plot the first point. The coordinates is 0.5, 1.08. So here is the point. And the second point, third point, and so on, right? So we have 5 points. Now we can use a ruler to join these points. Okay, we get a straight line connecting all these points. Okay, now from here we can start to find the constants p and q. So we know that the negative log q over 2 is the y-intercept. So this is the y-intercept. The value is 0.8. Okay, now negative log q over 2 equals 0.8. Solve this equation. Q will be equals 0.025. Okay, we also know that log q over 2 is the gradient. So we choose 2 points, which is easy to read the coordinates, and they should not be any points from the table. So let's say I choose this point. The coordinates is 4.0 and 2.48, and this is the second point. The coordinates is 0.4, 0.92. Okay, draw a right angle triangle to represent we are finding the gradient. So log p over 2 equals 2.48 minus 0.92 over 4.0 minus 0.40. We get p equals 7.36. Number 3. So given log y equals 0.7, so half log y equals 0.7, log y will be 1.4. So from here, by using the graph, right, 1.4 is somewhere here, and the corresponding x value will be 1.35. So this is the answer. Do you get the answer correctly? Now, let's look at one example related to the application of linear law. Given this diagram, the diagram shows the path of a stone thrown from point A on the cliff. It reaches its maximum height at point B before descending to hit the sea. The height of the stone, y meters, at the horizontal distance, x meters, is recorded as shown in the table. So here is the table. Given that x and y are related by the equation y equals ax squared plus bx, where a and b are constants, draw a straight line graph of y over x against x. Use your graph to estimate the value of a and b. Determine which value of y is wrongly recorded and estimate the correct value. Estimate the horizontal distance from the cliff when the stone is at point C. Estimate the maximum height attained by the stone. Here is the solution. From the given equation, y equals ax squared plus bx, we can divide x for both sides, which we get y over x equals ax plus b. Okay, so the capital Y will be y over x, the gradient is a, the capital X is x, and the c is b. Now we can plot the graph y over x against x. So before that, we need to find the values of y over x from the given data. So these are the values of y over x. Now we can use a piece of paper to plot a piece of graph paper to plot the graph. Okay, so this is the x and y axis, where the x-axis will be x and the y-axis will be y over x. Okay, and now we can start to plot the points here. Okay, the first point coordinates is 1, 7, so this is the point, followed by the second point, coordinates is 2, 8, the third point coordinates is 4, 6, and so on, right? Continue to the next point, and next point, right? Another point, and the last point coordinates is 12, negative 2. And now we can use a ruler to join this point together with a straight line. And we find that the first point is not on the line. Okay, so now we can answer the question, right, to find the constants, okay, for a and b. When we know that a is a gradient of the graph, okay, so let's say we choose the point, right, 10, 10, so the gradient is negative 10 over 10, which is negative 1. So the value of a is negative 1. And b will be the y over x intercept. So this is the point, right? We can see that the b is equals to 10. Number 2, right, the incorrect reading for this case will be y over x equals to 7, okay, which is y over x is 7, y is 7 as well. And the correct reading should be y equals to 9, which is at this point. Number 3, horizontal distance. So this will be the point that we want to find. So the x is 10 when y-x is 0. Number 4, the maximum height will be between x equals 4 and x equals 6. So this will be the point. And from the graph, we find that y/x equals to 5 when x equals to 5. Therefore, y will be equals 5 times 5, which is 25 meters. So this is the maximum height of the stone. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.